Read it out loud for you. It says the number of eagles in a wildlife preserve is modeled by E of t. So some important things to note about that. It says the number of eagles, right? So there are different categories. We often look at amounts of things versus rates of change of things. This clearly states that we're talking about the number of eagles when we're talking about E of t. T is time in days. Using correct units, please explain the meaning of the integral from 0 to 31 of e prime of t dt. So take just a moment. I feel like we've executed quite a few questions like this recently. I don't know that we've stopped and explained them as much as this one wants us to do that. So take a few minutes, write out your explanation. We'll check it in just a second. If you're having any kind of a hard time seeing this, what I'm about to write might be helpful. This would not be an explanation, but you might maybe want to write something like this to kind of help you see. Would this make sense? Based on all the net change theorem type of stuff we've done? Definite integral of e prime from 0 to 31 would be e of 31 minus e of 0. So that might help you as you think about your explanation. So I would say, as far as explaining the meaning of that particular expression, what would, I'll say it's like this, integral from 0 to 31 of e prime of t dt is the net change, right? You can see that in the little equation I wrote up there. So it's the net change. So your net change of the number of eagles some other ways to word that, you could say it's by how many the eagles changed, or by how many the number of eagles changed, or how much the number of eagles changed, or the eagles changed by this much. I mean, however you want to phrase that, but you basically have to express that it's related to the number of eagles and how many have changed, like how much that number has changed. So it's the net change of the number of eagles. If you want, I mean, I feel like you've already kind of given the units for the integral itself, right? Like the number of eagles. You might, if you wanted to be super redundant, you could say in number of eagles, right? I don't know that that's particularly necessary in this case because I've already kind of stated that, but this would be kind of a model for how we would give units. But then, really important, we got to express the 0 and the 31. What do the 0 and the 31 have to do with? Days, yeah. So you'd want to say something like from day 0 to day 31. So you want to include units with those numbers, the 0 and the 31. Let's see here. That's the net change of the number of eagles in number of eagles from day 0 to day 31. So something like that would be good. Question?
Is it okay if we just say like over the course of 31 days?
So that's often that will be accepted, but it's not the best because over the course of 31 days could be from day 30 to 61, which would likely be very different from 0 to 31. So I would say that's probably best, although that has been accepted for sure in the past. Yeah.
Why is it the net change, not the net amount?
The net amount. So it's the net change of the amount. Like, so when you say like net goes with things like net profit. I mean, that's the first thing that pops into my mind. Like the word net is always associated with some kind of change, right? So like if we said net profit, you are taking basically your revenue minus your costs to get your net profit. And so I don't know that net amount, I mean...
Could we say net amount of change?
Oh, yeah, for sure.
Okay.
Yeah, definitely. But net change really needs to be, or even change would be the more important word. So if you said it's the change in the amount of eagles, or change, I think you'd have to say change in the number of eagles, or change in the amount of eagles for it to be, like, grammatically make sense. I'd say change is the bigger word. Yeah. Anybody else? Questions? All right, so I think you'll see another example. Oh, question? Yeah?
If you wrote like sigma delta instead of net change, would that work?
Sigma delta, well, yeah, technically, yeah. That would work. I'm trying to think about, I don't know if I've ever seen that at the reading. I've definitely seen delta used a lot to just, equate to change, which, so, yeah, it would work. Nobody's ever asked that, but yeah, that works. Anybody else? Okay, fantastic. I think you'll see this question come up again right now. Take a look here, skip over that one. We already did the Camp Newton question, but we have not done this one. Okay. So this is a temperature of water in a tub. I told you they did a lot of water tank style questions for a while. Lots of them. Here we go. So let's, this is an old AP question. I'll read this out to you, the question stem. You got that table above. The table has to do with time and degrees Fahrenheit of water in a tub. You can see from the table, can you see that the water is cooling down or heating up? Which one do you see? It appears to be heating up, yep. All right, so it says the temperature of water in a tub is modeled by a strictly increasing. Man, whenever you see something like that, strictly increasing or maybe strictly decreasing, they're probably wanting you to do something with that later, so consider. Twice differentiable function W. W is measured in degrees Fahrenheit. T is measured in minutes. At T equals 0, the temperature is 55 degrees Fahrenheit. You can see that reflected in the table above. The water is heated for 30 minutes. Kind of curious because where does the table end? 20. So that means there's something else going on after the 20 minutes. Water is heated for 30 minutes, beginning at T equals 0. You got the values of WT above. The first 20 minutes are given in the table above. All right, so some of this is review. For sure, like I would say A is a review question, still valuable, still worth doing. B is definitely contemporary, so is C, so is D. So kind of like that last one, I guess. A is a review one. Let's go ahead and do A first. Give you guys just a couple of minutes to do this. And gosh, this I'm almost for sure would have been a calculator active question. Yes, I am for sure this is a calculator active question. So please do use that as warranted. Could look like this. This will just be for A. I'll just erase these as I go. So I'd say W prime of 12 is approximately, let's see here, W prime of 12. 12 is right between the 15 and the 9. So I think I'd use those data points there and there. And I'm going to go 67.9 minus 61.8 over 15 minus 9. Make sure you show that difference quotient. I want to see a difference in a quotient. And so that right there, as I was walking around, did that end up being like 1 point something? 1.017. Yeah, that's right. Okay, so 1.017. Okay, and then as far as what that means in the context of the question, I would say that there'd be two ways we could go with this. At this point, is it okay with you if I just erase that part and write down the explanation? Is that okay? Well, remember that it's 1.017. So if I was going to try to explain that, you could say 1.017. This would be the more generic way of doing it, is the rate of change of the temperature in, what kind of units would go with that? Per minute, I think, on this one. In degrees Fahrenheit per minute when T is equal to 12 minutes. So that's a little generic, but that I think would be very, very good full explanation of what that is. That make sense? Did anybody do it a little differently? Because it's very, very possible to have done this differently. Can I show you an alternative then? Check this out. You could say something like this. Because W prime of 12 is positive, the temperature is increasing by 1.017 degrees Fahrenheit per minute when t equals 12 minutes. A little bit different. I would say this is a little more applicable, right? A little more in the context of this question. I think the other one is just fine. I think this one would probably be considered the best, right? You're saying because the rate of change is positive, then whatever the rate of change is measuring must actually be increasing at that point in time. All right. I'm reading success, right? Am I seeing? Yep, we're good? Okay, cool. So that's old. That's review. B, C, and D are going to be not review. So if you would, take a look at B. So B says use the data in the table to approximate that. So let's start right there. When I see that, did you guys see this too? Where it's, integral from 0 to 20 of w prime of t dt. Did you guys write this, or at least think this? W of 20 minus w of 0? Yes. Did you see that? Because when you write it out like that, now all of a sudden the data in the table becomes incredibly useful, doesn't it? Because when you think, all right, well, what's w of 20? Well, it's right there. What's w of 0? It's right there. So this is where I think using that net change theorem concept would really make this one easy. So this one equals 71 minus 55, which is 16. Could we stop the... Oh, that was you making that lovely music. Yes. Okay. Anyway. Also in B it says interpret the meaning of that answer. Let's just do this verbally. Anybody want to volunteer an answer for this? Go ahead, Zach. Listen.
The sum of 0 to 20 of w prime of t dt means that the net change in temperature over the interval 0 minutes to 20 minutes is 16 degrees Fahrenheit.
You guys hear that? He said it really quietly, but it was really good. Will you say it again?
The summation of 0 to 20 w prime of t dt means that the net change in temperature over the interval 0 minutes to 20 minutes is 16 degrees Fahrenheit.
It's really well said, isn't it? Were you guys following along with that? Yeah. Maybe I could write it down for you too. You could say this is the net change of temperature in degrees Fahrenheit from 20 minutes, or excuse me, from 0 minutes to 20 minutes. I think that's about verbatim what Zach said. It was really well done. Okay. That change of temperature in degrees Fahrenheit from 0 minutes to 20 minutes. Yeah, I like it. That's well said. Very well said. Any questions, follow-ups on that? Okay, if you haven't already looked at C, please do. C says for the interval 0 to 20, the average temperature is given by that integral expression. Use a left Riemann sum with 4 subintervals indicated by the data in the table to approximate that. And then it has a follow-up question. Would this be an overestimate or an underestimate? Explain your reasoning. So try C if you haven't already. I would go 1/20th times the integral from 0 to 20 of w prime is approximately equal to, and I always really focus on the 1/20th because that's the thing I know that I'm going to forget. So I'm going to go 1/20th, and then let's see here. A left sum would look like this: 4 times 55 plus 5 times 57.1 plus 6 times 61.8. I don't know if I maybe can fit this in. Plus, finally, 5 times 67.9. So do you see how I use the left side every time? The left height for all those intervals? Please don't forget the 1/20th. That is, I'm sure you can imagine, that's like the number one silly mistake people make. They'll like do a great job with the left sum and forget the 1/20th part. So I'm just going, does it make sense on left sum concept? Yes? No? Yeah, Lainey.
So
Oh, why did I put a prime in there? That would just be an example of a silly mistake. I just wrote the wrong thing. Sorry, I was probably thinking about B still or something.
Makes sense, thank you.
Yep. Yes, that's got to be what it is. We'll put it on his shoulders. Okay. So anyways, did you calculate that out? What did you get when you did that? Sorry? Did you guys actually multiply this out and divide and everything? What'd you get? 60.79. Are there 3 decimals to be had?
No.
Okay, 60.79. If there's not 3 decimals, then you just put 2. Okay, and then as far as, is this an overestimate or an underestimate? This would be an underestimate. And here's what you could say for reasoning. Underestimate because W of t is strictly increasing on the interval 0 to 20. Underestimate, you want to connect that with the fact that WT is strictly increasing.
So if it didn't say strictly increasing, then could we even tell? If it was...
No. No, you really couldn't because you have no idea what's going on between each of those data points in the table. So they got to say something about it's always increasing. So, yeah.
So why does it be strictly increasing?
So why does that work? Yeah. Hey guys, here's the why on the strictly increasing. So if W is strictly increasing, then it would look something like this, right? Therefore, a left sum, which uses the left side of each interval, would look something like that. Therefore, each one of those rectangles would fall just a little bit shy of the actual value. So by extension then, if you got a strictly increasing function, a right sum would always be an overestimate, right? And you could kind of reverse that same kind of logic for a strictly decreasing function as well. So a little picture like this I think is kind of nice. This is far from conclusive reasoning. I mean, if you just sketch a picture out, it's not like that's my reason. But this really might help give you direction as far as what the answer could be and what's related to what. So, okay. Do you guys need any more time for D? Raise your hand if you want some more time for D. Walking around, I saw most people had mostly completed. Okay, so we're good. All right, so let's go ahead and look at D then. It says for 20 to 25, beyond the table now, W, the function W that models the temperature, has a first derivative given by W prime. Based on that model, what is the temperature of the water at T equals 25? So again, this is a little subtle trick. The table has to do with W, but then in D they give you W prime, and then they ask you for temperature. So anytime you're given a rate of change of temperature and you want to know temperature, what are you going to have to do? You're going to have to do an integral, specifically a definite integral, right? Calculator's active. We probably want to use Math 9. So I'm thinking if I did this, check this out. What if I wrote integral from 20 to 25 of W prime of t dt, and then I went on to use Math 9 and evaluate that. Would this give me my answer? No. What would this give me? Because this would be important. But this gives me the net change in temperature, doesn't it? Net change is not necessarily the same thing as the temperature. What am I forgetting if that's all I write? The 71. And what is the 71? That's W of 20, right? Yeah, that's the temperature at the start of my interval. What was that, Johnny? Did I miss something?
Oh, no.
Okay. Sorry. It looked like you were saying something important and I didn't hear it. You're good? Okay. All right, so 71 plus. So if I go 71 plus the change, this should give me the temperature at the T equals 25, which is what I want. So I hope that makes sense, like when you need to include the initial amount, in this case 71, maybe when you don't. Okay, so you use Math 9, 71 plus that integral. Jake, did you get this? What'd you get?
I got 73.04315.
043, I'll stop there. 15 sounds good too, but I'll stop right there. I didn't say anything about units. What would be the units for that 73.043? Degrees Fahrenheit. Okay. All right, so how are we feeling? It's okay? Have any follow-up questions on as a whole? Just by way of encouragement, I just want to let you guys know, remind you, this is an AP question. I know sometimes we look at these and we're just like, oh, gee, those AP questions are going to be almost impossible. And some of them are difficult. I'd say this would be like a medium one, say, something like that. And I feel like you guys did really well. I don't think that there was any like moments of extreme anxiousness and like, I can't do this, this is impossible. So just be encouraged by that. That already it's December 1st. We only have 6 months for you to get better. And you're already feeling at least sort of confident with this. So that's, to me, that's very encouraging. Okay, I want to do one last thing here with one part of our last example. We're not going to do the whole example because a lot of this last example is review. And I want to do 2 things with this. So turn over to this one, if you would, please. On this one right here, this one right here is pretty interesting, pretty unique question. So, part A is the one that we're going to focus on. Hey guys, if you could listen up for just a second. Here's what we're going to do. The function f is defined on the closed interval -5 to 4, and that's a graph of f right there. The graph of f consists of those 3 line segments. And here's where it goes a little bit wacky, right? Let g be defined as g of x equals the integral from -3 to x of f of t dt. So for the first time, we are defining a function as being like an accumulation function, right? We're going to be accumulating from -3 out to some x value. G of x is defined as being an integral. Kind of interesting. So I want to do 2 things with this. We are not going to do anything with b. We are not going to do anything with c. We're going to do something with A, and I'm going to have like one little small extension to A, okay? So A says find g of 3, and I want to just encourage you guys on something. Do you guys remember way back in Algebra 1 when you first learned about function notation, like f of x, g of x? When you first started your love affair with f of x, like everything's f of x? This one's g of x. So you remember this, right? Your teacher said, okay, f of 2 means plug in a 2. G of 3 means plug in a 3. I want to encourage you with something. It still means the exact same thing. It means wherever you see an x, are you listening? Not a t. Right? Remember, t's and x's are different, and they are truly different. So wherever you see an x, you plug in a 3. So for A, we could write something like this. G of 3 equals the integral from -3 to 3 of f of t dt. So literally, all I've done, I've not done anything incredible. All I've done, bless you, is I have replaced x with 3, which is what you already knew g of 3 meant, right? Wherever you see an x, you put a 3. This is where your guys' skills are going to be way different than some Algebra 1 person's skills, because now you look at that right side and you think, well, I might be able to do that, right? So you look at the right side, it says integral from -3 to 3 of f of t. So this is a definite integral from -3 to 3. How on earth are you supposed to evaluate that? If you can't integrate, or you don't feel like it in this case, just accumulate. Because isn't this another one of those cases where if you wanted to, you could figure out the linear equation for each one of those line segments and do these crazy integral split-ups and really make a mess for yourself. Or you could do what Peyton just said, and if you can't integrate, just accumulate. So let's do that. So I'm going to go -3 to 3. Would start with this area here, that area there, and then it would include this area. Let's go with this. Include this area right here, and we'd have this little chunk right there. So let's get busy trying to figure out some areas. So what is that black area?
Why do you separate it into 3?
I don't know, I just did. I'm just going, yeah. That's just what struck me. How about that area right there, the red area? I think it should be 4, right? It's 2 by 4. And then finally, the yellow area would be 1. 1/2 times 2 times 1. Okay, so then as you try to finally evaluate g of 3, we would say 6 plus 4 minus 1. And we'd get 9. Sir?
So the WebAssign that was due, like, I think it was Wednesday, had a few problems like this.
Okay.
Should we have known how to do that?
I don't know, maybe. Do you know how to do g of 3? I don't know. I'm not answering your question definitively. I'm answering your question with a question, and I don't know the answer to it. Maybe if you didn't make that connection, I don't know. Okay, I do want to show you one other thing, though. I would like to show you one other thing. Does this make sense, though? I hope that it does. So here is the other thing I'd like to show you. So let's say we had a question D. And let's say question D, do I want to do this? I do. I do want to do this. Let's say question D said this. Find G prime of negative 3. Oh. So this is actually a lot easier than you think. It really is. So, guys, I want to take you back to the very first part of this year, really back when we first started doing derivatives in like September. We found G prime of X, we found F prime of X, and then very quickly thereafter, didn't we find like G prime of 5 or F prime of 6? The ordering on this is incredibly important. If you're going to find F prime of 6, what do you have to find first? You have to find F prime of X, and then you plug in the number, right? If you want to find G prime of 9, you find G prime of X first, and then you plug in the 9. So the ordering on this is the same. We have to go in that order. So if I'm going to find G prime of 3, I have to find G prime of X first, and I want you to think about it like this. You've got an equation for G of X, don't you? And if I write G prime, aren't I differentiating the left side?
Yeah.
Pay really close attention. If I differentiate the left side, don't I have to differentiate the right side too? Check this out. Equals d dx of the integral from negative 3 to x of f of t dt. Do you recognize that? What is that? It's not f of t, it's f of x, right? This is fundamental theorem of calculus, part 2. Doesn't d dx and the integral basically cancel each other out? This is FTC2 from a couple days ago. Don't we simply drop the x in there?
Yeah.
Multiply by the derivative of what you plugged in. In this case, that's just a 1. So you'd get g prime of x equals f of x. And since we got a graph of f, this should be pretty easy now, right? G prime of negative 3 would equal f of negative 3, which would equal 0, right? Because right there's f of 3. Okay. We good? Question?
Could you do it another way by just like not deriving or f of t and just saying like f prime of negative 3 minus f prime of negative 3 because they would be
Well, f prime
of negative 3 would be the same in both instances.
f prime of negative 3?
Sorry, because like the integral of that would be
Not f prime.
never mind.
Yeah, it would be
But like-
capital F. It'd be
Because
something different.
the definite integral is the same two, like
It's the same 2.
has the same end bound. Wouldn't the change always be 0 because it's not going over any
No.
distance?
No. The answer won't always be 0. Like if I wanted you to find g prime of 0, the answer would be 4. Because wouldn't g prime of 0 equal f of 0?
All right, buddy.
Well then on
There's
the,
f of 0.
on
See you, Ben.
yeah.
Does that make sense?
Yes.
Okay.